Right, hi guys. Hopefully the past several hours have been really useful and full of very valuable Unreal Engine 4 information. We're now kind of taking a step back from the individual details of the engine and talking about general kind of project, team, organization, especially kind of with a focus towards small teams building mobile games. And I've got a whole set of slides here, but they all kind of have a bunch of information and a why on them. And the why for this one is, the most successful teams are not successful by accident. They're deliberate, they plan, and they're organized. So we're going to talk about, setting up a game project, how you pick the technology you're going to use, and not fighting that technology, but using it in the way it's kind of designed, in the way the platform it's on is designed. Talk about team collaboration. Talk about source control management, bug tracking, organization, a bit of QA, some UE4 specific stuff, some monetization, and some analytics as well. So first off, talking about building game projects, picking an engine. And why would you pick an engine? Well, you want to pick an engine so you can focus on building your game. You don't have to deal with the various things we've talked about today about platforms and layers and different input targets. You want to pick a piece of tech that complements your game idea. Pick tech that is forward-looking so that as you continue to develop your game and new platforms come out, your technology runs on that. And then you should plan to build and kind of heavily customize your own secret sauce for the game. If the engine can build your game almost instantly, or if any engine can build your game almost instantly out of the box, it'll be very easy for people to build competing games. Your idea should be unique and have key pieces to it that require a bit of extra work and really make it your own. You need to make sure that you're picking technology and you're not fighting your tools. Game development is hard. You want to get the most out of your work. You should be looking at technology that has a scripting system. Blueprints, visual scripting versus regular old scripting, either are fine. Some sort of C++ core engine for performance and platform portability. Some sort of game object system. The ability to take content from Max or Maya or other tools. A level editor, other pieces, profilers, cookers, just networking, whatever systems are required for your game. But you should be looking at the technology you choose for your game and making sure that you're not fighting it, that it has the things you need and you're using it in the way it's intended to be used. So you picked your technology. Now you're talking about team collaboration. You want to effectively stay in touch with your team. A lot of companies will found an office and work there, but there are a number of really successful teams that are working entirely distributed. You'll need both real-time and delayed communication methods. Skype, Hangouts, Slack, QQ. Any of these are real good real-time communication methods, as well as just walking over and talking to somebody. You're also going to want some delayed communication methods, wiki, message boards, emails, so you can both share information when people aren't around and archive key decisions you've made for future use, so you can go back and discover why you decided on something. Source control management. Well, why would you do this? The real answer is hard drives fail eventually, always. Given a long enough timeline, your hard drive will fail. There are a lot of great tools out there for this Git, Perforce, Subversion, and there are some really cool tools that aren't quite ready for prime time, such as Dropbox, Google Drive. That they tend to kind of lose content. It's not really what you want, but they may be cool in the future. Additionally, by using a source control management solution, you can not just prevent the inevitable hard drive failure, you can easily share your project and your code between numerous people working in various geographic locations, as well as see the revision of your code. So you can see how much work's gone in or when certain bugs are introduced, and you have a kind of time-lapse view of your project. This will become more important later on when we talk about QAing our game, keeping track of when major bugs occur, even if we don't fix them, and understanding how we're going to deal with performance regressions, if any happen. And again, since we're at GitHub, Git's a great tool for this. So you've identified that you're going to use a source control management solution, and now you need to know what to check in. You don't just want to throw every file into this. You want to keep your critical files safe. Art source, your U asset, your U projects, your source code files. But what don't you check in? Well, you don't want to check in anything generated because it's just regenerated and you're going to clog up your SCM. You're also going to have to stomp it regularly. It's just not worth it. So Unreal backup files shouldn't get checked in. Generated files such as Visual Studio Project and Xcode and Unreal Engine shouldn't get checked in. There's a gray area here for PDBs, executables, and the derived data cache in Unreal Engine. So PDB files are the generated program debug information that Visual Studio spits out. The executables are the actual executables that you compile. And the derived data cache is kind of the semi-cooked data that the engine uses to run, such as cooked textures and shaders that you really don't want to have to generate every time. If you're all working in a localized office and you've got a very fast network, it might be worthwhile to check all of these in and use your SCM as a way to distribute content and share content. And I know Git is going to talk later about their large file support, and that will actually allow this in Git moving forward. However, if you're kind of distributed, these files are all very large, and it may be faster to not have gigabytes of these files in your version control system, in your source control management system, and instead have everybody generate them locally. It's a tough call, but here you're balancing, size of content you got checked in, file transfer times, and compile times. And there are different things you can do. In Unreal Engine 4, we've got a derived data cache server you can set up locally that will help you kind of share this content outside of your version control. At Epic, we don't check in the PDBs or the DDC or the executables anymore, but we're also sitting on very fast computers on a gigabit network. So it's not a challenge we have. If you were working on a bunch of laptops in an office together, all on very fast Wi-Fi, you might find that it's better to check these in and share them over your source control management solution. Repository layout. So you want to make sure that you've always got a working build, no matter what, so you can reduce your turnaround time on critical fixes, and you can demo as needed. So if you're using Unreal Engine 4, we'd encourage you to have a clean repository from GitHub, which is your code gotten from our GitHub account, an intermediate, a working copy, and a last stable demo. You really want to maintain that last stable demo because you never know when you're going to need to demo for someone, a publisher, or just a friend, and having that last stable demo is very important. So this is kind of a better visual of how it will look. You're going to have code from Epic's Perforce or Git, most likely Git, that you're going to pull down and then put in your clean SCM branch. From there, you'll branch that into the intermediate branch. Then you'll branch your game over, and you'll merge and resolve conflicts. Then you'll merge that back into your main copy, and that should be a clean merge. The goal to be doing all of the merging work in this intermediate branch, so your artists and programs can continue to work in your working copy no matter what, and you can delegate kind of this merge work to one person in a branch by themselves. With a layout like this, we've seen many teams have great success taking regular updates from Epic Games, but they've also the ability to look back through time as to when they took updates, what challenges they had, and even get bug fixes in ahead of time if they needed something critical that was, say, in a preview release but not in a final release. And of course, off to the side of this, you should have branches for all of your latest demos, because in a source control management solution, an extra copy of the file doesn't really take up any space. It's just kind of a pointer. So you can have a branch for every single demo you've ever given, but it'll allow you to pull those very easily without much work, which again is important if you're trying to find regressions or if you're just trying to showcase for a publisher or a friend. So you've established kind of your SCM strategy. How often should you take updates from Epic Games or whatever your technology provider is? Taking a new engine version takes time, and you have to balance getting new functionality with fixing bugs and just building your game. They all take time. Well, you should take critical fixes when you've got a critical crash, right? If it's going to block your team, you can unblock your team by taking new code, take new code. Twice a year is a good frequency. Once a quarter is a good frequency. You should probably plan to take your last update 6 months before you plan to ship. And a few months before critical deadlines. You want to make sure that you're not expecting kind of the latest version of your technology you're getting to solve all your problems 3 weeks before you launch. It's not a safe bet. So we've talked about keeping track of our source code. Now, bug tracking. Stability matters, especially when you want to keep that nice demo branch for your publisher up and running. Now, what matters here is that you're tracking bugs, not how you're doing it. So depending on the size of your team and your game, you can use anything from Post-it notes to kind of extensive software such as Test Track, Handsoft, or Jira. Google Docs or Excel sheets also work. The important thing here is you're tracking bugs and you're recording and dating and timing them, right? You've got your source code under a source code management solution that has date and times attached to it. Now you need bugs to go along with those. even if you're not going to fix a bug, knowing when the bug started happening and which source code was changed around that same time will make your lives a lot easier down the line to help you fix these things. Team organization. If you empower your team, they're going to be much happier, and they're going to be more successful. And you need to know if you're on track. You should have an elevator pitch for your demo, for that publisher we talked about. You should have a timeline. You should have a plan for where you are, a design doc, and a process for deciding new features. You don't want your entire team to be building separate games all on their own without a unified vision. So the earlier collaboration methods we talked about also really help here. But overall, having a structure and an organization where you can decide new features, understand where you're going, understand where you are, and make sure you're aware you're on track can be very important as you're building your title. QAing your game. You need to know when things break, even if you don't fix them all immediately. You should test your game weekly at the bare minimum, daily if possible. You should automate testing the key path of your game, either through AI or through other methods. And you should test your game on the target hardware regularly for performance reasons, and the lowest end target hardware. Don't build your game on just the highest end piece of hardware and then be surprised later on when you find out that you've got poor performance in the low end piece of hardware. And again, as we talked about with our bug track and our SEM, if you QA your game regularly and you discover when things break, even if you don't immediately fix them, by recording that and acknowledging what changes and the source code that happened around, when you have to come back and fix it later, you'll be in a much better position to resolve the issue, and you'll be able to make sure that you can solve that problem with much less time than if you didn't do this. So we're going to be a little UE4 specific here, but you need to make sure when you set up your project, you set it up with collaboration in mind. If you make it fun and easy to work on your project, folks will enjoy working with you, and the team will really enjoy building the project. Make sure you set up any Unreal Engine levels with layers and streaming levels. Give everybody their own layer to work in. That way there aren't merge conflicts when you try and get this content into your source control management. Create sandboxes where your team can work on experimental things without putting that straight in main and impacting the rest of the team. Set up a folder structure that will scale with your project. If you're building some sort of RPG with 1 million weapons, make sure you've got a naming scheme and a clear folder structure for where those 1 million weapons are going to go, so you're not searching for them across your hard drive. A little bit of planning here can go a long way in making a team more successful. And again, the most successful teams are not successful by accident. They have the experience and the planning that makes them successful. Be collaborative in building your game. If 2 people edit the same file, you could lose one of their work. Now, the source control management solution should let you diff and merge several files, so that'll save you in some ways, but it won't save you all the time. UE4 has an integration with Perforce, SVN, and Git from within the editor. So as you move around things in your level and save, it can, behind the scenes, save your files to Git or any other version control system and check out files as needed. This will, if you're careful and have the layer set up properly and are working collaboratively, will allow you to kind of all work independently without stopping each other's changes. Visual Studio and Xcode also have Git and SVN and Perforce integrations. So for your artists and your coders, there are solutions here, assuming you've got some basic collaboration going on to make sure people aren't editing the same file. But this should make it fun and easy to build, not be a frustration point. And again, the worst thing you can do there is have 2 people edit the exact same file and a binary file at that, and have one of them lose their work. Distributed computing. You've got a team working in an office, you can share CPU and GPU power. So Unreal Engine uses what's called the Derived Data Cache, or DDC, and there, the first time a texture is used by the editor, it's compiled and saved off, or a shader is compiled and saved off in a format your GPU can use. And then by saving that DDC to a network share and setting up Unreal Engine 4 properly, you can end up in a situation where only the first person that ever imports a texture or generates material has to compile that. Everybody else just pulls it over the network. And for a large game, this can end up being hours of computation time if you have to generate it on the spot, or basically free if it happens gradually over time. The light baking solution for static lighting in UE4 called Swarm can also be run across many CPUs and GPUs. IncrediBuild will do this same thing for C++ if you've got a team of programmers all iterating on a game. And last but not least, Unreal Engine has a nice side tool that will allow you to set up a single Mac in your in your office and then have everybody from Windows shell out to compile to it. So you can buy one high-end Mac device and have a team of people building on PCs, but we can still then compile the iOS build from PC without having to walk over to it. So if you're in the same office or you have the ability to share hardware and computers, you can actually get some pretty solid team performance and kind of development wins by setting things up properly and thinking about how you're going to collaborate and distribute some of your work. Game choice, right? The other stuff was all kind of hardware setup. Now we're getting into kind of the abstract, When you're building a game, your game can't be all things to all people. You should be explicit about what kind of game you're building, and that should be empowering. You should know what your lead platform is. You should understand what your minimum specs, your minimum device is. And you should target one type of input at a time, either touch or controller or keyboard or something I haven't thought of. But trying to do too much at once will lead to kind of confusion. Focus on lead platform, be aware of your min spec, target one input type at a time. It's much easier to take a really good working idea on your low bar platform and up-res it or change input than it is to try and simultaneously develop something for all platforms. Mobile game considerations. As we talked about today, mobile as a platform isn't as mature as PC. It's much more fragmented. Make sure aware of your texture format, your GPU architecture, and your OS. And again, hopefully the tips and tricks you've received today from folks like Alan, Smedis, Zach, and the CCP guys will help you be more enabled and more aware of this stuff and just more successful in the future. Online game considerations. If you're building a mobile game that has a backend service, make sure it's robust and affordable. Backend services can be anything from analytics and ad providers to networking and push to play. You should know what your cost is per download, even if this is just for distribution and not for gameplay at all. You should know what your cost is per user, your average revenue per user, and the average revenue required per user to keep your game afloat. There are many other important data points you should also track: retention rates, bounce rates, how are people coming into your game, how many are staying, how much money are you making. All of this is just some good basic business sense, but in the mobile marketplace, as crowded as it is right now, it's important that you're aware of this and that you're launching a product that can be successful. Interesting side note, when Epic Games put out Unreal Engine 4 for free, we were not surprised by the number of people downloading the engine, but we were very happy with it. However, if Amazon charges you 2 cents per gigabyte and the average Unreal Engine install is 8 gigs, you can imagine the bill we got for data hosting alone for Unreal Engine at last GDC was quite large. So, building a min viable product. Communication can be difficult. Talking works, but different people have different ideas. To get a publisher financing or a platform approval, nothing shows you can do work better than having a narrow path demo, and nothing prevents communication issues more than having everybody able to visualize and see what you're building. So build a narrow path demo or a min viable product. Run it on the target platform, build it at target art quality, but you can fake interactivity and gameplay. Just show that your visual bar can be hit and that some of the gameplay interactions are fun and engaging. Just a very limited slice, but again, building it on the target platform at target art quality shows that you can deliver on your vision, and then faking gameplay shows that the gameplay can be fun even if only the parts that are supposed to work, right? It's okay if you can't wander off somewhere and do things that aren't really key to the gameplay. This is to make sure you're communicating your vision to your team and potential investors or publishers or platform holders. So, multi-platform development, cross-platform tools like Unreal Engine are very powerful and they can make your lives easier, but they're not magic. Talked about earlier, focus on one input type at a time. Use your scalability settings. Know your GPU architecture, the number of lights you support. Be aware of your memory footprint. Different devices have different amounts of memory, and it's very easy to go over on some devices. Understand your download, delivery, patching process. How are people going to get your game? How are people going to update your game? Who's responsible for paying for that bandwidth? How much of your game do people need to play? Can they play with just a small initial setup, or do they have to download the entire thing first? Use custom profiles to maximize performance and quality on each device. And then again, make sure your lead platform is your least performant. Make sure you're building your game on a daily basis on the platform you think will be the most trouble, not the easiest. Shipping. Well, shipping is a feature. You have to make sure that you've got a schedule and that you have a plan to get your game performance to ship. Too many games end up taking too long simply because there's always one more thing you can add, and that will only take another couple months. Make sure that you have a plan and that you have labeled shipping as a feature in your bug track, in your production plan, all of this. It is a feature, and just because it's game shipped doesn't mean you can't iterate on it and build it out more. Nowadays, a lot of games are shipping in one region early on to get feedback. Like I mentioned last slide, a lot of games are shipping in one region early on to get feedback and keep it going. So post-ship considerations are that after you've finished the game, you need to put the time and effort in to make it successful and potentially build it out further. There are a lot of tools available, and there are a lot of great talks on this available in other locations. But things like A/B testing, adding adverts to your game, monetizing your game, looking at your user acquisition funnel, and then make sure that your communication, your networking infrastructure for the game, if it requires that kind of stuff, is well established and is ongoing. A/B testing. You should be validating your hypothesis about what users want to do in your game. Test in smaller markets, make changes to your live game, and you can test everything from gameplay to your game's icon, and then implement the player feedback that you get from this. There are a lot of talks about this out nowadays, as there are a lot of mobile games doing this kind of thing, and I've seen some really fascinating ones where people increase their sales simply by changing an icon to something that look more appealing. This is very important and is an easy way to take a labor of love you've built, this big game, and increase the user engagement simply by making small changes, but you'd never know what they are unless you start testing for them. And again, there are a lot of good talks out nowadays about this kind of thing. Analytics and monetization. Real-time insight into your game's performance will enable you to tweak it and potentially make more money from it. There are a lot of individual kind of third-party things. There's AdColony, Tapjoy, and many more. We've got kind of an abstract plugin for this in the engine so that you can implement your own, or as more plugin providers decide to roll Unreal Engine versions of this, you can just kind of drop them in and switch them out through INI files. Again, our goal here is to make it fun and easy after you've built the game to continue to expand the game and make it more and more successful. User acquisition. Again, the mobile market is crowded. Understanding the players who want your game and identifying how to grow to your audience will be very important to you. You can purchase advertising on Facebook and Twitter, in other apps. You can get them through many websites. You can do this all based on audience profiles or who you think will enjoy your game. You can also work with a third party who's an expert in this space. There are many of them out there, and they'll probably bring more insight than you would have on your own, having done this for other games and other styles of games. They bring a level of sophistication that probably you as an individual studio or an expert game developer may not have. That's it. More than happy to take any questions. If not, we can let the GitHub guys come talk. All right, thank you.
So we're just going to kind of open up the floor, and this is also a good chance. If anybody wants to exchange any war stories, things that you've learned, we can do that here.
Hello?
As someone just kind of entering the whole dev project, what's the best advice you'd give to like a brand new team?
I think the first several slides of that presentation are kind of the most important. There are so many ways for an early team to kind of falter and fail by not properly setting up plans for source control management, bug tracking, QA, and a narrow path demo, just to identify to make sure the team is all building the same thing, or at least think they're all building the same thing. It's just this set of slides is generated based on 10 years of experience supporting teams, and it's all the things I wish teams thought about all the time. I expect that everybody in this audience was aware of 75% of it, but it's always a different 75%. Whenever we go to a different studio, there's always one piece that they're kind of missing, especially in the new studio, in the new team area. So I get those things about setting up processes in place to make sure your source code is working, to make sure you always have your narrow path demo, to make sure you are tracking bugs, really important. Joe, up here.
Can you use web technologies for A/B testing, like with the HTML frames, like within the game? So, like with if you use like a Meteor JS, you can do like a hot code push to push
Could
changes.
you hold it a little closer, sorry?
Oh, like with Meteor JS, you can include hot code push, which is you can basically update the game to get quicker testing.
Yeah. Yes, I mean, there are a lot of things you can do to A/B test, and it really kind of varies what you're even trying to test, right? If you're trying to test an icon, you probably have to upload a new APK to some sites. If you just want to test, say, like individual in-game choices, you might drive that with JavaScript or an INI file. One of the things that Epic did early on in the Gears 3 timeframe, not even Unreal Engine 4, but Unreal Engine 3, is we drove our multiplayer kind of map of the week all through INI configurations that were downloaded dynamically. So we didn't have to update Gears of War 3 at all to change what a multiplayer match looked like, and even per region, right? So if we wanted to do like a shotguns only event just in Texas, we could. Mm-hmm. And little things like that are really powerful tools because they allow you to see how different areas react. Now, depending on what you change, you might have to download a whole new app, right? If you're swapping out character animations or if you're changing source code, there's a lot more you have to do to test it. So it's such a broad topic that it's hard to kind of cover it extensively, but there are things you can do at almost every level. There's probably every member of your studio can think of a couple things that they can do to A/B test things to see if they move the needle. All right, thank you.